matrix that's 200 by 200 by 200. So, and I think 10 or 20 million particles. So simulations like that. That's 200 by 200 by 200. So, and I think 10 or 20 million particles. So, is there a simulations like that? That's 200 by 200 by 200. So, I'm hearing an echo. Are you guys hearing an echo?
Yeah.
That was me. My bad.
That's okay.
I'll never forgive you.
I sometimes think it's my machinery.
No,
This is one of those IT things. Oh, it's not working. I quit.
Put the table. All right, we'll start. We'll get going now. It's 7:11. Figure maybe a few more people will trickle in it, but everyone else can just watch it on YouTube. Start with the meme. This is about how my programming experience goes. Anyway, switch over to get started here. All right, folks. Oh no, that's not how I want to do that. I want to do more like this. Do the fun virtual background. That's the one. Cool. We are getting rough. All right, guys. Do we have any gals tonight? Ladies and gentlemen of the YouTube lands and the guys of Zoom at the moment, welcome to another edition of SacPy, Sacramento Python Developers Meetup. It's November 4th, everyone. 2021. It's still a pandemic.
Yep.
Oof.
Oof, indeed. Welcome. All hail our glorious founder, Josh Miller. We haven't seen him in a few months, but he'll pop in from time to time. He started this at some point in the last decade. We were in person at one point. We'll probably be back in person at another. We used to meet at Urban Hive. I think the Hacker Lab or something like that said they'd have us next. But it's been a while since I've seen you guys in person. I feel like I've seen Tanim more times on Zoom than I've seen anyone else on at any of the in-person ones, but I feel like I know you. It's kind of a cool part of Zoom. Yeah, Josh Miller got this thing started a while ago. He passed the torch to me January of 2020 when he got shipped off to the East Coast for a new gig. I was lined up to do a presentation and he just said, "Oh, I gotta go. You want to take this over?" So that's how I ended up in this. We got some chat channels. If you guys aren't on there, these links might work. Those QR codes should work, I believe. Take a screenshot, if you will. Look at them later. I'll try to put the links in the chat. But we're on Slack all the time. Some group called SacTech put together the Slack. I also have a Discord channel that I run for my company, Brazen Studios. But yeah, I'm usually in those. I'm pretty responsive. Follow us on Twitter, join our subreddit, join the Facebook group.
Look at the subreddit, see if it's how active it is.
I think it might be even one person beyond myself. It might just be me though. Wishful thinking. If you build it, they will come. Maybe one day it'll take off, but who knows? I tweet occasionally. I tweeted about today. I feel like the Twitter is like fairly okay as far as the traction goes. We're over 100 followers, so hooray! I think the group has a few dozen people. Page has a few dozen likes too. But yeah, look us up, SacPy. Except on Twitter, Sac_Pi. There's actually someone his name is just SacP, I think. It's ridiculous. All right, let's try to do one of these things. How do I do it so I can look at the gallery mode? You guys can.
All right.
Turn off your camera or turn on your cameras. We'll do a real quick group shot. Oh, where's my camera? Oh, there we go. All right. You don't have to if you don't want to. Oh, there you go. John's there. What about Mr. Stubler?
Hey
Yeah.
guys, how are you?
All right. Hey, on three. 1, 2, 3. Cool. All right. Thanks, guys. Turns out the bigger those things get, the more frame there is. So I think we're almost to the next round. All right. Getting on to our presentation today. Well, it's not really a presentation. This is going to be the first of hopefully many interviews we do with SacPy. Typically, we'll do kind of lectures where people come and do a show and tell, talk a little bit about some project they're working on, usually focus on some Python libraries and maybe other interesting parts of the stack. Tanim has volunteered a number of times to present for us. Once again, thanks for all your contributions, man. It's been you've been a great community member.
Thanks.
So finally, we had someone lined up until like a week ago or something like that, and it's been a little crazy on my end. So I reached out to Tanim and said, "Hey, you want to go to like riff on something?" And then I realized, oh no, these podcast things, they're typically, like interview type things, and apparently someone had interviewed him fairly recently, and I remember hearing he's done some pretty cool stuff. So thought we'd kick that off, or thought we'd like kick off an interview series with a pretty interesting dude. So if everyone could real quick, take yourself off mute and say, welcome Tanim on 3. 1, 2, 3.
Hey,
Welcome,
Tanim.
Cool. All right. So we'll just go to straight talking here and stop this share real quick. Let me pull up my interview questions, but I got it, kind of the questions I'm going to ask, but if you could just give us a quick intro. Dr. Tanim Islam, who are you these days?
Who am I these days? I'm a staff scientist at Livermore Labs in Livermore, California. And I've been there for 10 years. I do a lot of interesting things. Just like right now, I'm working on a laser-driven experiment that's probably going to be fielded sometime soon. And looking at some historical, particle data that I think it's probably 30 years old now. And the third thing is some kind of Navy system that I'm contributing a tiny bit to. So 3 things that I'm working on right now. And I guess I also hack onto Python a fair amount, probably too much, but it's great for what I want it to do.
Awesome. Well, let's start with the beginning of your higher education. You are a grad. You got your bachelor's in physics at Caltech.
Yep.
So what was it like down in Caltech? That's down in Pasadena?
That's right, Pasadena. It was really intense. It's a fire hose. So I think I studied way too much. I should have enjoyed it a little more. Maybe taking an extra year to graduate, that sort of thing. But I made a few friends. I actually had more fun, after first I repressed my memories for the first 10 years after I graduated. And then I had a lot more fun going back and reconnecting with a lot of people who I went there with. After that, I was at MIT for 3 years.
Let's stick with Caltech.
Yeah.
Stick with Caltech for now. We'll go to MIT next. But
all right. What's special about Caltech is a lot of studying. I didn't get enough sleep.
Yeah, I like the insight. You wish you'd done 5 years, done an extra year just to.
Yeah, just an extra year, just so I could have the chance to relax or take parts of it easy. Actually enjoy my time there, that sort of thing.
Nice. Yeah, I swim in school, and I kind of wish I had done something kind of similar. In sports, you can do what's called a red shirt. I wish I had taken a year off just to I don't know, have a bit better rhythm, because when you're full time on athletics and academics. Like you said, it's a fire hose. So
It is.
it's rough. So I have a friend that went to Caltech. A couple of friends, or both of the brothers went to Caltech. But we were talking about earlier that there's something they do called the Ditch Week stack. You said
A ditch day.
Ditch Day stack.
Yeah.
So in their time, they had it was some like campus party thing, but they had like a pirate ship and they swung onto it to start the party.
Oh, wait, did they say which graduate dorm house they were? Sorry, undergrad dorm house they were in? Because
Ooh, that's getting
what I talked about was sort of just a puzzle that like the seniors make for the underclassmen. No, I think this sounds like one of those parties that they had. Like each undergrad house has one of those. It looks like maybe either Dabney or I think Dabney or Ricketts might have had one of those things. Probably Dabney because they do these big productions. I guess it was in the that square, in the middle of the in the middle of the dorm. That's where they put all their stuff. I think they all of them do it that way.
Now you're calling it one of those parties. I guess this is maybe why you wish you had done another year.
Or I mean, those parties are okay. Really, everybody there is studying too hard, or at least that's been my experience. So, yeah. I did make a lot of good friends there, though. So I don't miss that. I do miss that sort of experience.
Any of them do Python? Should we get them to speak in the future?
If you can find them, sure.
Well, maybe
they probably got families and obligations and.
Oh yeah, that whole thing.
Sure. Yeah, I mean, I could if people want to talk about Python, yeah, sure. I guess they could.
Cool. Well, hey, if you can think of anyone or find out, maybe like posting something on your LinkedIn. You're awesome, but it's good. Fresh blood is always welcome. All right, so MIT was next.
Yeah.
You did plasma physics there.
Mm-hmm.
So what? All right. First off, what do you do with plasma physics? Is that like nuclear? You make? What do you do with that?
Yeah, you could have nuclear fusion stuff there. Anything that's a plasma. A lot of the work at MIT, I didn't do that work. That work was on these magnetic fusion reactors that people were working on, or doing research design, not real design, because there isn't really anything out there. But like MIT had its own research fusion reactor there at the Plasma Science Fusion Center. That's where a lot of those grad students in plasma physics work. Others did astrophysics or astronomy. Some did mathematics. There's a lot of stuff. So I did mine in the end on plasma astrophysics, or that was the research I did.
Nice.
Boston's a great place. I mean, it's awesome. You don't need a car there or anything. So it's, yeah. I wish I could have stayed, but my advisor and I didn't really get along. So I transferred after 3 years.
Right. Classic Anakin scenario. Like we grant you a seat on this board, but we do not grant you the rank of master.
That's one way of looking at it. Yeah.
All right. So it was off to that was a master's program though, right?
It was, well, I mean, I was in the PhD program. It's
PhD
just
program. Okay. So I mean, but you're still Dr. Islam at this point because UVA was next.
Yes, that's where I finished my PhD in astrophysics. So I started at UVA, and then did the last 2 years in Paris because my advisor moved there. And Paris is a pretty fun place.
Wait,
got a lot of good food there.
back to. Oh wait, no, never mind. Plasma physics. I was going to ask if you met this one professor at MIT, but I realized he's probably younger than you because he's younger than me.
Oh,
He's also not there.
probably not.
Okay, so you moved from plasma physics to astrophysics. At least we're
Uh-huh.
keeping the physics theme. What precipitated the change there? Like,
Well, I mean, it was a plasma physics topic that I started at MIT,
Right.
or it was my last year and a half. That's what I worked on, and I figured if I want to transfer, I want to, maybe start from scratch again. So I, asked one of the big names in, plasma astrophysics in that specific problem if he'd be fine, taking me on as a student. And he said, yeah, I mean, with the application. And so that's what I did. I did my PhD at UVA. I got it in it was December 2007. So, yeah.
all right, so that started out actually in Virginia, right? Charlottesville.
Yeah, in Charlottesville, Virginia.
But then you ended up in Paris, and you said you were in the fifth.
The fifth arrondissement, yeah.
How
Yeah,
long?
I had an apartment not too far from the place that I work, the École Normale Supérieure, also in the fifth arrondissement. And yeah, it's a lot of good food around there. It's actually a pretty touristy place. There's one street full of restaurants, ice cream shops, I think crepe places. There's like 20 crepe places on that street. And I pretty much go there morning, noon, and night, for food. On the weekends, I'd go someplace else, also in Paris, just take the metro to get really, really good Vietnamese food.
Vietnam's a French colony, wasn't it?
Yep. Also Cambodian, Laotian food.
Or
Surprisingly, Chinese food is really bad in Paris. I mean, I tried Chinese food there, and it's really, really bad.
it's probably because you need to use oil and not butter.
I don't know what they did. I mean, you can find better Chinese food at a small town anywhere in the U.S. than you can in Paris, which really surprised me.
That's do you miss the bread? That's what I miss about Paris.
They had this thing called a galette de roi, so king's cake.
Oh yeah,
Uh,
a little toy in one of the slices.
Yep, that's right. Yes, but they only had it during the month of Epiphany, so month of January.
Right.
And yeah, it's my favorite pastry because it's got that almond butter thing inside and phyllo dough. And there's this one place in Livermore back in the day used to make it. First it was on the menu, then it was on order, but that place went out of business. So now it's the French style because there's also the New Orleans style or Louisiana style king's cake, which is more like a beignet or a donut. This is more like an actual pie.
Right. I think I've had them once. One of my exes is French, so she made sure we got that for what was it called? The month of
Epiphany.
Epiphany. There we go. Some sort of E. All
This
right.
is a French Catholic thing.
All right. So now you're doctor of astrophysics. That's kind of cool. You're like space doctor.
No, like Dr. Octagon, huh?
Yeah. Dr. Octagon's a rapper. Dr. Octopus, maybe? No, but so that brought you to your first job at NASA.
Uh-huh. Yeah, there I was a software engineer doing some air traffic control management research, just supporting the NASA, scientists who are doing air traffic management stuff, like improving the airspace, developing the next generation, which is, I guess, like semi-autonomous, flying things, talking to other flying things to keep them out of each other's way. This is all actually more than 10 years ago now, like 13 years ago. And one of the things I worked on was this thing called FACET. I don't even remember what it stands for, but it's
Well, I got it right
you know,
here.
the National Airspace or North American Airspace Simulator. So, it's just,
Future Advanced Concepts Evaluation Tool.
yeah, it's basically, you can give it a bunch of, flight plans from historical records or simulate it, and it'll, just simulate that. And so you can do research. It's like a mini, North American airspace over a day, a week, a month, however long you want it to. It'll show what all the planes were doing.
That's pretty cool. I had a friend who worked on some prototype for what they thought was supposed to be a more user-friendly air traffic control thing, but they basically put it in light mode. And I'm realizing now that like air traffic controllers are the like OG dark theme users.
Yeah.
What's that all about? They're always, I guess you need air traffic control more at night than during the day.
Or maybe it's easier on the eyes. I don't know. I actually never got the chance to go to one of those things, so I don't have too much of an idea of how they work. There are people who do research on those air traffic controller kiosks and things like that. But I worked on sort of the overall airspace. Like, okay, what if we improve our scheduler or something like that? What effect would that have on, the airspace, like over an airport or over a whole region, that sort of thing.
Yeah. So how difficult does that job become in the world of, like Jetsons flying cars?
Oh, yeah. The big thing when I was about to leave was drones. Like drones, having them, file a flight plan or something like that. Or that was the idea in over an airport or something. And I completely lost touch with that. I don't know what's happening in that whole space right now. Maybe, as far as I can tell, I don't see too many drones flying over airports. So maybe we haven't gone that route.
Maybe the interesting airspace thing right now is the thing that people are getting all up at arms about with the Starlink. Not that there's nothing out there, but
that's out in space. That's like astronomers don't like it so much, but it might have an issue, like maybe colliding with some satellites that are already up there. I actually don't know, but I think air traffic management's, in the atmosphere is so well below that stuff.
Right. All right. What else do you do at NASA? That was an interesting one because you did it through UC Santa Cruz. Like they were
that was pretty much it that I worked on at NASA. Just air traffic management stuff. That was, yeah.
So what precipitated the move to your present station at Lawrence Livermore National Labs?
Yeah, I wanted to go back into physics, and the stuff at NASA, although it was interesting, it wasn't really what I wanted to do. And so I applied to a bunch of places and interviewed at Livermore and some other places like Sandia, Los Alamos, and I got the job at Livermore, which I was really happy about. And that's what I've been doing for the past 10 plus years now. I've been a staff scientist there doing this and that.
Nice. Well, no, this and that. Back at NASA, you were considered a software engineer,
right?
But I noticed in your academic career, you did all these physics things. At what point did you pick up software engineering?
I think I got sidetracked. I guess over those 3 years that I didn't get the postdoc that I wanted, and because of that, I was graduating and I wanted maybe something in software engineering. I wasn't really quite sure what I wanted, so this was, sort of a job that paid fairly well, and it was in the Bay Area. So I thought, okay, let me try this out. And, like a year and a half into it, I thought maybe this isn't for me. So that's when I started, in the second year, after 2 years, I started to look, in other places. And I knew I wanted to go back into research, or a research area if I could. And so that's what I did. It all worked out in the end for me.
Nice. Now Ames is Moffett Field. That's down in Mountain View, right?
That's right. Yeah. It's close to Google.
Yeah, that was it. It was literally straight across the street from the campus I was on when I was down there.
Wow.
Was Hangar 1 or whatever there?
Yeah, the ones that held the blimps, the giant dirigibles during World War II. Yeah, it was there. Hangar 1 and 2 were there when I worked there and lived in Santa Clara.
Yeah, we would bike from our campus down to this other campus called Tech Corners, and we'd go right past Moffett. It was always kind of cool. I was like, oh, look at that, it's NASA. This is weird.
I guess you could go up to the Mountain View Winery, or I forgot what it's called. It's all the way, you go up to the west end of Stevens Creek, past Cupertino and up the hill.
Mm-hmm.
And if you go to the top or drive to the top, you can see all of like the South Bay and a little bit of, San Francisco. And one of the things you could see is, Hangar 1 and 2 right by the bay.
Yeah.
Right, just south of the bay.
Yeah, those things were cool. They're like they kind of half dome things, but weird superstructure. Cool. So, all right. Now you're at Lawrence Livermore. You've got you list on your resume, you've got 3 unclassified sets of projects. Does that mean there are classified projects, or are they so classified you can't say?
No, I mean, I can describe it in general, but yeah, the ones that I can fully describe, I think I just showed the unclassified projects.
All right. So first up is prompt diagnostics of fast events and sub-microsecond and nanosecond.
Yeah.
Insanely
So
fast.
these are, some experiments, some, fast neutron or gamma ray experiments. You just, pulse neutrons into some critical or near subcritical assembly, and it spits out, neutrons and gammas. And I model both how those neutrons and gammas fly out and the detectors that used to, figure out the signal, modeling the signal from that pulse of stuff that comes out.
Now you're not doing like real-time processing of that data, are you?
No. This is more like, this is an actual, it represents, it's a model of some experiment that's going to be fielded or has already been fielded. And we're saying, okay, maybe we can have a better detector. What more can we see? Or, okay, can we, given our detector like a sort of high fidelity model of the experiment, what can we infer about the behavior of the thing that we're trying to measure based on what we actually saw, that sort of thing. I think data science folks call it an inverse problem. That is, what can we infer from the thing that happened based on the thing that we see?
Nice. Now, are you doing that with Python?
Yeah, a lot of it with Python. The code itself is this Monte Carlo particle transport code, but parts of it you could steer with Python. I have my summer student and I wrote something that reads in that data and does a lot of visualization and processing. And yeah, I live in a Python land quite a bit. It's because there's a lot of support for Python, and it's a pretty nice language to write in. And there's a lot of numerical stuff there, like NumPy and SciPy, is what makes it really work well for scientific computing. And so Python.
Caleb asks, I think they meant inference rather than prediction.
Yeah. It's well, yeah, that's really, since a lot of my work is historical, it's mostly inference. So it's like, okay, this thing actually occurred, and this is the thing that this detector sees. What does that mean? Say, how many neutrons or gammas this thing emitted? That's the sort of thing that one of the things we infer from whatever happens, a few meters or 10 meters away.
Gotcha. All right. So Brian says something which I presume is some sort of classic Monte Carlo scenario, bullets and airplanes.
Oh, are you talking about the fact that the statistician said, okay, the Air Force, or it was the Army Air Force in World War II, found, okay, there are all these bullets here, but these are the bullets that they saw in, planes that, bombers or something like that came back from their bombing runs. So the Army thought, let's just put the, more shielding over where the bullet holes are. But the statisticians, this is sort of I don't know what it is. I forgot I'm not a statistician, so I don't remember the vocabulary term. But it's a selection effect. That is, okay, you know that these things already came in, but there are bullet holes there. But so you know that they came in despite the bullet holes there. You don't see bullet holes in sort of the clear parts of the wing. So the thing to do is maybe further reinforce the parts where you don't see bullet holes. And so more of these bombers will come in rather than, don't reinforce the parts that get the bullets. So I think that's the survivorship bias. Okay, that's what it is.
Yeah, I've seen that one a bunch lately. I hadn't heard the survivorship bias part though. That's cool. All right, so I think you shared a YouTube video earlier.
Yeah.
Maybe I can pull that up real quick here, but I think it was one of your simulations.
Yeah.
The next
outputs. Yeah, so it was this extra bit of physics that I incorporated into high altitude nuclear explosions, but it's neat to see, okay, in about half a second, what happens to the plasma debris from a nuclear explosion up, high up above the Earth's atmosphere, this magnetosphere. And that's what, I intended to show. Basically, what do those charged particles do? What happens to the magnetic field? The plasma from the nuke actually, pushes out the Earth's magnetic field like a balloon. And because there's field lines there, it also spirals, along the Earth's magnetic field lines too.
Now, is this one particle movie? Why not slice 150 kilometers?
Yeah, this is this thing nuke that went off, 150 kilometers, and we're looking up down basically.
All right, let's see if we got. All right, is that moving?
Yep.
Ooh. Now, what are you drawing something like this with?
So each frame of this PNG was created with a tool called Visit. Oh, this is the y equals. Oh, sorry, we're looking on the side. Sorry about that. This is not up down. We're looking on the side. So going down is towards the ground. Going up is up further up into space. And this is looking at a slice. I think maybe 5 kilometers or so thick.
I think it's at 150.
Yeah, but like if I showed all the particles, it would be like since it's a 3-dimensional phenomenon. Let's see if I've got it. I think I have some more ones where I look at it up down. Let me see.
Right now, Caleb's asking the real questions. Did you get to set off your own nukes? So you're getting
no, nothing like that. I didn't even work on experiments at the laser that produce DT neutrons through fusion. You know, so there are a lot of people who do that sort of stuff. I didn't even do that, so that stopped in '92, at least in the U.S. No more nukes after '92.
So what data were you pulling from? Like what nukes? These were, I guess, pre-92 nukes.
Yeah, this was actually a mock-up of a nuclear explosion called Starfish Prime, which actually, you know, is probably around a megaton. It went off 400 kilometers above Johnston Island, so about 1,000 kilometers away from Hawaii. And with that nuke that went off, there were like a bunch of sounding rockets that went off almost simultaneously, that launched almost simultaneously, because people wanted to figure out not only, okay, what's happening, you know, as they see it on the ground, but also sort of like magnetometers and things like that. What was that plasma cloud, you know, that happens, you know, under a second after the nuke detonated? See what it looked like. What was the magnetic field like? Can they identify what that plasma debris looked like? Okay, as they went across it. That's right. It was actually really a really tough engineering thing, because these rockets had to fly up and go off within, I think, basically, and, you know, start recording, you know, within a less than a second, probably 0.1 seconds, you know, after the nuke went off. Because otherwise, if it goes off, if it starts recording too late, then, you know, it's not going to see anything. So it was really, really hard to do. There was, I think, 15 of them that went off, that went up with it, and 12 of them got useful data. So that's really, really tricky to do. And rockets are pretty unreliable things even now. And they did this in 1962, so.
Nice. All right, any other questions? Yeah, nukes are fun. Do we have any other questions on that? Oh wait, here we go. Spencer's got one. Couldn't you simulate a nuclear explosion and analyze it?
That's what we do a lot of. This is this stockpile stewardship, you know, work that I do. At a high level, that's what me and a bunch of people do. We simulate a nuke, you know, occurring somewhere on the earth, but in a computer. And we try to figure out, okay, given, you know, how old this nuke is or stuff like that, will it still go off how we think it'll go off? And that's a lot of what both Livermore labs here in California and Los Alamos in New Mexico, that's what they do.
Nice. So the next up, you had high energy density Reshark experiment at this place, the National Ignition Facility and Omega.
Yeah. So this was
tell us about.
This is a laser that acts as a really powerful hammer. You know, turns it into a plasma and has pressures up to, you know, tens or hundreds of millions of atmospheres in that tiny region where this actually plasma mix experiment goes off. So we shock it, we move it. This thing, you know, is basically something, what is it? Heavy on top of light, and it's decelerating. It causes something called a Rayleigh-Taylor instability. So the idea is maybe we can, you know, see how this mix layer develops under these really exotic conditions, something relevant for these ignition capsules that, you know, we field at NIF and some other places to try to get ignition. Maybe we can learn a little something about the mix that happens under these extreme regimes that occurs in those experiments. And that was sort of the modeling and design work that I did there for maybe you know, about a year and a half.
Well, nice. So you've presented a number of times here at SacPi.
Yeah.
Done. I'd say the biggest one was the COVID map that you made.
Yeah.
One of the most interesting points I think you've glossed over in the past was the fact that you're running this thing on like a supercompute cluster.
Yes. So I'm generating about 26 of these movies, or movies for 26 regions. I think there's 2 movies per region, so 52 movies. It's all in Python. So, basically 100 plus calculations. And if I tried to do it serially, it would take forever. So I split it off into, 8 or I think 9 nodes on the supercomputing cluster. So it's all done in about 45 minutes, and it's updated daily at I think 2 in the morning. It gets the data from the New York Times COVID-19 database and then creates those visualizations. And I can give you the link, and you can, probably, if you want to show people what I'm talking about, I can.
Yeah, sure. Send it over.
Sure, let me see where it is. Oh, shoot, I forgot. I think it's.
Well, I'll post the link to this YouTube video and we can link it in the description.
Yeah, let me see. Actually, I'll say. Let's see. I'm giving the link here. Here's the continental US, 7-day COVID cases and deaths, like 7-day average new cases and deaths. And here's one here's Sacramento. But yes, so this is an MP4 file. So, if you want to go towards the end, you can see the delta peak right over here at the very end.
Mm-hmm. Where is that? That's like, oh, I got that thing in the way. But it's the one at 600, it looks like 600 days.
Yeah, exactly, or 500. Well, I mean, there's a trough at 500. This was when
right,
we all thought,
the
worst is past, right?
Right. And then nature did its thing with mutations.
And this is, different from my stockpile stewardship work. This is sort of hobby-like work.
Yeah, this is the, how did you describe it? This is showing up to the company picnic with extra Tupperware.
Oh, that's, you show up with extra Tupperware, and
yeah, they're gonna
you just steal the, what is it, paper towels. That's how you separate your desserts from like normal lunch or dinner, picnic food. So you don't have it mixed together. I suggest at least a gallon, Tupperware container.
You're gonna throw it away anyway.
You might see something happening on later days. Florida, this is the deaths on top. Florida counties stopped recording new deaths per day by county, but they still reported new cases per day. So this is Ron DeSantis, I guess, had this idea. Something's happening with Nebraska. You can see there's a big hole in the middle.
Oh yeah, that was crazy. Wait, I don't know if anyone caught that. That was crazy though. Go back.
But yeah, yep, there it is. See,
nothing's going on here. Oh, except for like a few.
COVID.
What was the deal? There was like a few counties that were rebelling against the blackout or whiteout.
I guess so. Yeah.
Whoa, it's wild when science and politics meet.
Yep.
Dang. All right, so moving on. I see you've done a little bit of research in the past. You got at least 5 papers listed on your site there.
Yeah.
Did you use Sphinx for any of them? Because
no, this was a lot of it was it was pre-Sphinx. So
well, Sphinx
is something I really learned how to use in the past two and a half years. for my hobby projects, actually. It's like, okay, I want to document this stuff for myself and maybe for other people. And Sphinx has a bit of a learning. I mean, yeah, the restructured text, that's the markup language that Sphinx processes to create these web pages. It has a bit of a learning curve to it, but once you figure it out, and then nowadays, the documentation on how to make it all work are my Sphinx websites, which in my case are part of my GitHub repos. That is the source documentation, the source to make the documentation websites. I just look there to see exactly how I did this or that, and you can do quite a bit of stuff. You can have figures that that you can refer to by their numbers, same as with LaTeX. You can actually refer to external code with plugins like Sphinx.
Right.
And
No,
you
LaTeX.
can even do LaTeX math too. So if you have equations in there,
All right,
you
so
can also draw that up.
we're being a little self-referential here. We've lost Caleb. Sphinx is a library that Tanim presented on in the past. Sphinx works from Python comments, as I recall, and creates.
That's where it started off. The language, the markup language called restructured text, started off as a way of representing Python comments, like code comments. But then it grew from there. It
Restructured.
got enhanced, and then Sphinx happened, which made it a lot more polished. It's probably easier to show rather than to tell. So let me see if I can. A good one, I think GitHub. This is the Sphinx document. I'm giving the link. This is the Sphinx documentation too. I think it's the Python project that I use basically all the time.
Now, latex or latex or whatever you want to call it, that's kind of the standard for producing white papers.
Scientific papers, scientific and math, and some engineering papers. Yeah.
Right.
And so it does, formulas really well, like equations and formulas really well. That's what it's really known for. It's also got a very nice tooling to do, figure table references and bibliographies. So, but it's kind of old. It's been showing its age for a while. I've heard of Graph. Man, Graph, all that stuff, Yep, MathJacks. You actually have the choice. MathJacks is, I don't know if MathJacks is a default for restructured text. It is for Sphinx, but there's also math.css. That's another option. Actually, maybe math.css. It's called LaTeX Math or Math LaTeX. Or you don't need a special plugin. A Sphinx plugin for MathJacks is the one that uses that JavaScript library to make really polished, LaTeX formulas on your web page. And there's also Image Math, which is taking your LaTeX formulas and equations and converting them into PNGs, which is okay. It's yeah.
All right, so I'm looking at your list of papers here. I see two of them. You worked on things called Airspace tube networks.
Yeah, those were some concepts that some next generation air traffic concepts to
Is that like
handle more traffic. I think that was the idea.
Gotcha, like corridors, not like a system of tubes that we.
No, these are corridors, dedicated corridors.
Oh, okay, man. I was picturing like Futurama stuff with. No, okay, cool.
Maybe on the moon.
Oh, yeah.
Yeah,
Well,
so Brian, it can do that. Yes, you can actually have Sphinx documentation with these formulas that can display properly. And I actually have. It's funny you mentioned that because you can actually even blog in restructured text. So let me see if I have an example of that. Okay, let me see. I can give you a link where it has restructured text that's rendered using MathJacks. Gosh, my internet is being wonky. It's being very Comcastic. So
Hey, your audio's great this time. There were some times in the past it was a little choppy, but
who
great.
knows how any of this crap works?
Yeah. It's probably just your FBI agent messing with your packets.
It might be. Oh yeah, I'm sure the service has gotten Comcastic again.
I can't win them all.
Anybody here work for Comcast here?
I saw something where it's like if logos for businesses or like mottos for businesses were honest. My favorite was the Comcast one. It was like Comcast because F you.
All right. Gosh, where did I put? Oh yeah, okay. So here's the one. I think that has a lot of formulas in it. So that's an example of using LaTeX in restructured text and having it render pretty nicely.
All right. Tanim drives slow. My philosophy on driving.
Actually, this is even faster than I drive. My maximum acceleration's 5.5 miles per hour per second. So that means in a, what is it, 60-foot, turning curve, like going from one road to the other, I'll go 15 miles an hour. That's what I'm good. That's my target speed, maximum speed on that.
Spoken like a true physicist. All right, so you've done all this research. 5 papers is pretty respectable, I'd say. Do you know what your Erdős number is?
No, it's not very high because I haven't written enough papers.
No. For anyone who's unaware, Erdős numbers are, there was this guy, Paul Erdős, he was basically a traveling mathematician. He would travel around to companies and show up and say, my mind is open, and then work with them, reduce their business problems, science problems, engineering problems into a math problem. And then he'd work with whoever they kind of figured things out with. They'd publish a paper. And then, it'd be one more person in this very long list of people that he worked with and published papers with. And in the end, he ended up producing more papers than any mathematician ever. I think Euler was, I think, the closest to him, but he published well over 1,500 papers.
Yeah. So.
And in the scientific community, he became so popular literally by publishing, not simply the fact that he did fine work. That's why he published a bunch, but like you could literally track and get an interesting stat saying like what your number was relative to like how
distant you were. Like, I think if you're a direct collaborator with them, you have an Erdős number of 1.
Yeah.
And maybe the Erdős 1 club, there's probably levels to how many papers you've collaborated with him on, that sort of thing.
Yeah. And then Erdős not, of course, was Erdős himself.
Yes.
And then I guess Erdős 1, he's dead now, so Erdős 1 will eventually expire. But
yeah, if all his collaborators die, that's true.
Yeah, so your best bet is to get to 2 at this point, or your best possible performance is to get to 2.
Yes, at this point, yes.
Unless you figure out
2. Like if you collaborate with a collaborator,
right?
It's 1 + 1. That's the closest you can get now.
I was trying to plug it into the calculator.
It's the minimum, I think.
1's the minimum, but it's impossible to achieve that level these days because you had to have done it with him.
I think it doesn't change. Once you're at 1, you stay at 1, unless your paper's retracted.
Right, or you somehow become Erdős.
Right.
But yeah, I want to figure that out someday. Okay, so all right, moving on. GitHub, I'd say you got a pretty good presence on GitHub. Oh my God, someone's calling. Let me get ahead of that one. So GitHub, so far, what would you say the project is you're most proud of?
I think it's the Howdy. That's the thing to manage my Plex server, which contains movies, TV shows, and music that I, listen to constantly. And it's stuff, it's a workhorse. I mean, I think it works pretty well. It has to because I use it all the time. So for instance, I have a System D unit, the cron job equivalent that checks for new TV shows a few times a day at night, because that's when they come out, or early in the morning for the previous days. Just goes through my library, queries the movie database for new TV shows, and gets what it needs to get, and then puts it in the right folder.
Nice. Can I get an invite to your Plex?
Yeah, sure. Actually,
yeah.
There's a blog article too that tells you how to join it.
Oh man, sorry, I should have looked closer. I saw that you were talking about Plex. I was watching stuff on Plex earlier. I have a friend who does something similar, although yours is that's storage intensive. Although I guess maybe it's only which shows you're watching.
Yeah, or which ones people requested. So like I have The Simpsons on there. I've been watching 30 Rock again after, a long time.
Nice.
I didn't realize, I forgot how funny that show was.
Yeah. Well,
Community, The Office. Oh my God, there's so much crap on there.
Yeah, 30 Rock was back before Alec Baldwin had shot anyone. Ooh.
Right.
Soon.
8 years before it ended 8 years before Alec Baldwin, shot people on set.
He's getting rusty. I think maybe you have the same thing set up. A friend of mine does on Plex, where it's like, he's got people on there, and then like if you go and search for something, it'll automatically download it so that it goes onto the server and you can watch it kind of live.
Oh yeah, there's things like called Sonar and Radar, which act in an automated fashion that way. The problem is my Plex stuff happened on a much really underpowered machine, and when I tried to set those things up, it would just crash. It would just use up too many resources. Plus, it was just really unwieldy. I mean, I could never get it to work. Like, okay, it would take forever to index my, media. And so I was like, I don't really need this, but I'd like the functionality. So I just coded up a few things that does a lot less than those things, but, and it's all steered through the command line, as well as, server crap. So, and it works pretty well.
Hey, we like server crap. Cool. All right. So moving on, we'll get into the end of the questions I got for you. So you did software engineering at NASA, but I'm assuming well before that you did some development programming, as it were. What was the first thing you remember programming?
I think it was HyperCard. This is probably early 90s. That's what I did. And then I didn't really do much programming at all. I did, college, it was Mathematica and a little bit of MATLAB and Maple. I tried to do C programming and some Java, but it didn't really go very far. I really only started doing Python programming once I started at the lab, like really hardcore heavy Python programming.
So just within the last 10 years, that was the next question.
So, 10, maybe 11 years.
Now, was that self-taught or was that a prerequisite of starting?
Yeah, pretty much self-taught. So I might still have a lot of bad behaviors or bad habits, but I try to optimize away a lot of that, because bad behaviors tend to waste time. So if I've got to do a lot of programming, and I got to do a lot of programming that I'm going to use, but my experience is it does tend to improve. But I don't do stuff like over engineer. So there's not a lot of classes, an object orientation in my code. Like if you look at Howdy, it's really a bunch of methods, I guess, heavily documented methods with a lot of examples in some of them, but not something like, okay, here's a subclass or parent class, and here's the child classes that inherit from it, and the work lives there. Yeah, I do programming by expediency, and a lot of it is just stuff, programming paradigms or things that make sense to me that don't cause me such a big headache. Of course, my stuff isn't all that complicated. It's just, a lot of it is just, okay, I need to get this thing out of this data structure. So for Howdy, it's like, okay, I just have to like create code that, slurps in from an API, from an API server like Music Brains for music, or the movie database for movies and TV shows, and gets the information for me. Or from Plex too. Actually, I query my Plex server to get, the current state of movies and TV shows that I have on there.
All right, so, oh no, my internet connection is unstable.
Oh, Brian, you mentioned YouTube-DL. If you used it recently, you might have noticed it's gotten a lot slower and crappier. There's actually a replacement called YT-DLP is the replacement to YouTube-DL. Which this is a fix I made like maybe 2 or 3 weeks ago. So I was getting so frustrated by the fact that the music I was trying to collect took like an hour, half an hour, when before it would take like 2 minutes to get the whole album. And so it turns out that, yeah, YouTube-DL is probably a bit rotted away at this point. And there's like API equivalent, just better implementation called YT-DLP that does it, and which is just as fast as I and everybody else are used to. Like, I think MPV, I don't know, this Linux movie player. It used to use YouTube-DL to, as a backend for, viewing YouTube videos on using MPV. I think it was replaced with YT-DLP. You can set the same, you can just do a replacement because the, method calls are identical.
Nice. All right, so now you got all these libraries you've done stuff with. It looks like you've done obviously things with SciPy and NumPy. What would you say is a library that you've been considering for a while, but you still haven't really gotten into yet? Like, why are you looking at it, and why haven't you done anything with it? And if you did something,
maybe Torch, or I'll say Torch, because
that's machine
people
learning.
haven't said great things about TensorFlow for neural networks and more machine learning stuff. I'd like to get into that because there's some interesting research topics I want to explore in Monte Carlo transport, which I might be able to explore. I probably need somebody younger than me and more of a data scientist to actually tell me how to do this, collaborate with, to figure out how to, set up distributions, particle distributions using PyTorch, I think. I mean, if you know about Wasserstein GANs, Wasserstein distances, how to compare two distribution functions to each other efficiently. Yeah, we should have a convo.
Yeah, let's do a SacPy paper. I want to, like, if we write a paper with Tanim and he can at some level be traced back to Paul. So it's ERDOS, but then he's like some European origin. So
Hungarian
it's
guy.
pronounced. He's Hungarian. There we go. Yeah. So, crazy pronunciation. But I think basically you just need to write a paper with like almost anyone. So long as you
Yes.
write a paper with someone who's written a paper with someone,
Like
you'll
Kevin
get some.
Bacon, right? What's the
Yeah,
maximum British score you can have? Maybe 6
Yeah.
or 7.
Yeah, no, that's a good question. Like if you write one with like what is the lowest Erdos score maybe?
It's 0,
No.
but like of the highest, like
Yeah,
I think
yeah.
maybe 6 or 7. It might be the highest one.
Oh man. Wait, but maybe we could figure out how to get the highest.
Yeah, I mean,
Just collaborate with someone with the 7. So then you
or
can be
you just if you've
8.
never written a paper before, could be like infinite or something like that, right? 2 people who've never written a paper before, if they just write a paper together, right? Then I guess they would be, maybe it wouldn't be a score or infinitely high because they would not be connected.
There's gotta be there's gotta be a weird like moat around the Erdish population. And then, like psychology people or something like that. No, but maybe that was the thing is like he was like Kevin Bacon, where he would go and reduce any problem into a math problem, just covered like literally everything and
He
anything.
did a lot of stuff. That's true. His Wikipedia article I hear is pretty good.
All right, PyTorch.
PyTorch, yes. So the idea is neural networks or blah blah blahs to create and maybe characterize the posterior of covariance matrices that closely match a distribution of particles. That's really the idea.
I know
And the
this guy.
distribution function is made from the collection of particles. That's the skeleton. But then it becomes, okay, what are those covariance matrices that'll be a close enough match to the hypothesized distribution? That's it at a high level. I don't want to like oversell my work. That was really the research topic. One of the really interesting research topics I worked on by myself and with some summer students. One summer student in particular. On maybe we can do something better.
Oh, and then can we like auto generate the white paper in LaTeX with Sphinx or Howdy or whatever?
Well, Howdy is it's purely copyrighted. So auto generation, there's stuff like GPT-3 I heard that can generate human language like papers or literature, what have you. I actually use Grammarly a lot. I love it. I can't recommend it more. I mean, if there's anything longer than a paragraph on the open side, I just go through Grammarly, at least one pass of Grammarly, because I have lots of mistakes. I make lots of mistakes, lots of goofy errors in my writing.
I found this website recently called rephrasely.com, and it just you pass it a sentence and then it'll say it again like in a different order. Just plagiarize, rephrase it, boom.
Oh, I thought maybe to make it sound less direct, like you start off with "you're an idiot" and it probably tries to soften that language.
Yeah, no, it'll give you like a dozen options. One of them will be like Yoda style, "An idiot you are." All right. So when it comes to like projects, let's say Python projects, how have you picked your projects in the past?
It's honestly been well, there's work-related stuff. I needed to do stuff for work. For some of the work stuff, it was to scratch an itch because there's only so much that the group of people, say, supporting a code can do. And so a lot of it was I needed to get some simulation data out. And so I had to code up my own Python to read the data and do processing on it. There's some of that, just necessity. Others are to scratch an itch, like the COVID database, NPR stuff, which is like one of my oldest projects right now. That's where I learned how to like take some of the NPR podcasts and turn them into, download those episodes on my computer. Then it got expanded into a bunch of multimedia tools. I talked about that. That was one of my first presentations to SacPy, like tools that I made to scratch an itch, like auto cropping images. It sounds like such a crucially useful tool. It was so useful, and it doesn't take a lot of effort too. I just coded something up to just do that automatically. Tools to compose a bunch of, images as a movie frames into a movie. That's a big, part of stuff that goes into the COVID-19, stats repo. That's how I create the movies. It's basically a bunch of the frames, images representing a state on one day. So you have 600 days, that's 600 frames, just convert that into one movie, an MP4 file. Howdy, it's like I've got all this stuff and I don't want to manually download new TV shows. So it started off as a command line tool, just, type it out and it'll, basically search through your library, search for new episodes, download and organize them. And then I made a cron job equivalent on that. Same stuff for movies. For music, I hear something on Shazam and I want to maybe, have that song on my Plex. So that's what I did. Actually, I haven't done web app programming or Flask in a while, but I learned that by just going through the Ashley Madison database. I remember that hack from 6 years ago now. It was I think it was a MySQL database. So I downloaded that, downloaded a torrent of that, and I created a website. So you give it your Google credentials, like your Google email address. It'll go through your contacts. Of course, you have to give it permission. And it'll email you the lists of hits it found from your Google contacts in the Ashley Madison database. It was a nice icebreaker for my 20th high school reunion, just.
So for anyone who doesn't know, Ashley Madison is like a matchmaking website, right?
Yes,
like,
well, it's a fake matchmaking website.
You're still finding people in your actual contacts.
Yeah, it was great for that. It's sort of like, okay, who do we know, has an email address in the Ashley Madison database?
Nice. Now there's an itch to scratch. Oh, we missed one from Caleb from earlier. He asked, what was the term for comparing distributions?
It's this thing called a Wasserstein metric.
Wasserstein. Is that 2 S's?
That's what it is.
Oh, wait, Brian was, people looking for affairs? Oh, man. Dang, Tanim.
Well, I mean, it was, I remember reading a news article on Slashdot about it. Here's Ashley, it was hacked, and here's a torrent for it, or magnet link, and okay. Let me get that. And it's a SQL database. So, one of the first things I did was, basically look for the email table. I think that was one of the tables. I looked for any, LLNL.govs and LANL.govs and Sandia.govs. And this is how I knew that Sandia National Lab is the best national lab, US National Lab. Zero Ashley Madison hits with a Sandia.gov. Those people know what they're doing. They don't use their Sandia email address for that sort of thing.
Uh,
There are 5 from Livermore. There are
No.
5 llnl.govs that I know of because I checked, on what is the phone book to see if they were active.
That's amazing. Well, Sandia just blocks the website or something.
Maybe, but I choose to believe that they're the best national ad. They hire the best people.
Right, most disciplined as far as their data.
Yeah, they're not complete idiots.
That are just they're all bachelors and bachelorettes. No
Maybe.
one cheat or something. I don't know. Where's Sandia? It's like New Mexico or something like
There's
that.
2 of them. The big one is in New Mexico, and the smaller one is just south, across the street from Livermore.
Oh,
Livermore Labs.
nice. All right. So, well, obviously, we know how. The next question was like, how do you go about figuring out how to start a project? So that actually kind of segues nicely. So you start with itch to scratch, and then data set.
Yeah, God.
And an opportunity, apparently.
That is a good question. I don't know if I'm such a good person to answer that. I remember for the COVID-19 data set, it was like, okay, what's going on here? And the New York Times, made a really nice data set. And so I thought, let me see what I can learn from it. Okay, what's happening in California, what's happening in New York. And so that's just what I did. It just went through it. I mean, it started getting bits and pieces here and there, and then it became, here's some figures, here's the actual, data frame for what happens, in these counties. And then it became, well, here's a movie, here's what happens cumulatively. And then, probably 8-9 months ago, here's stuff to get the 7-day rolling average. And then shortly after that, here's how to do it 100 times per day in parallel every day. So I don't know. I guess it develops organically, and I'm thinking, well, I think a question to ask yourself, regardless of skill level, where you are, is what really interests you, and what do you want to figure out, know, or try to do, and see. And I think in a lot of cases you can do that in Python. The nice thing about Python, it's, in my experience, a great language to actually program in, and there's a lot of documentation. There's just a huge community out there to tell you how to do it.
No, absolutely. I think that the way Guido had things set up where it became easy to publish something so that it was easy to download and easy to, I don't know, you kind of like gain a little reputation if you get a library out there. So in a weird way, he's kind of gamified it to like instigate and encourage open sourcing of projects.
Yeah.
Look at Twinkie go, or whatever. Twinkles. Sprinkles.
What does she want to do? She just wants to go on this. She wants to fly around. I think she wanted to fly on to the top of this monitor.
All right. So last question before we, just open it up to anything else. We got a bunch of people relatively new here. I still think I'm pretty new myself. In general, for newbies, like, what do you recommend for I don't know, just how to think about building your skill set? What would you recommend for like getting started and really,
Oh, again, I'm not great for that. I mean, I guess I'm sort of a self-starter, and I had just some.
Yeah, but you said you've got students that you mentor.
What?
You have students in the summer usually?
Yeah, I have summer students, and they do the Python, the work-related Python projects that I need them to do. Like one of my summer students developed a tool for processing this Monte Carlo code's data output. It's called Caduceus. He wrote most of it. So, and I think he learned a fair amount of Python programming that way. But something like that, is pretty useful to not only me, but to a bunch of other people who work in that space. So yeah, I have summer students. I give them something that I know it's not sort of busy work. It's actually useful stuff that I and others will, continue to use. So yeah, I mean, if you guys are hard up on something, there's a lot of neat enhancements I want to see with the COVID-19 stats repo, which will be, I guess, useful to other people actually in this biomedical field. We can have a conversation there. I think I can sort of see where I want it to go. It's not, it's not completely open-ended, but yeah.
Yeah, I've asked in the past, and I think maybe the answer is, well, it's kind of political. It'd be interesting to see like data on different aspects of COVID, like how many tests are being administered and how frequently. I'm sure it's pretty hard with anonymized data to see, how many people haven't been tested and then what people have been tested numerous times. It'd be interesting to see who's been tested the most.
If that information is there, sure.
Yeah, well, it's not. I think I've looked a few times, and there's no good way to pipe that kind of data. But I don't know. It's funny to see. You pointed out that bit with Nebraska, where there was a good.
There was
month.
a gap for a while. They just didn't record it or report it.
Yeah, exactly. But yeah, it's an interesting one. Well, I wanted to open up the floor. I've run out of questions here. So far, great answers. It's always fun to see how your mind works there, Tanim. If anyone wants to, please feel free. Fire away if you got any questions. We've been taking them off chat, and those have been some pretty good questions so far.
Yeah.
What do you got for us?
Anything else? Dope, thank you.
Well, I'm not hearing anything. I'm not seeing anything.
I know it's a lot of stuff, but I got my GitHub page. I got my blog. So stuff is here and there and everywhere.
I get curious. Oh, sorry.
Yeah?
About you're talking about using Torch, which I'm taking as a deep learning program platform to do some kind of particle analysis. I'm wondering if you could talk more about that. That was really interesting.
Conceptually straightforward, sort of an optimal, minimized loss function of the distribution function and the actual solution space. The solution space is, a collection of covariance matrices for each of the points in that distribution function. So the thing you're trying to optimize, the best fit distribution function to basically a collection of particle data. In 1D, for instance, an example is you've got a set of points that, samples from a Gaussian distribution. Well, this would be over-engineering in one dimension, but it would be something like, okay, can I use some kind of Wasserstein GAN or whatever neural network solution is to figure out for each of the points that it gets, what's the optimal covariance. In 1D, it would just be this variance or standard deviation that best fits this hypothetical distribution. So that's what I meant by the Wasserstein metric. It has its most transparent form if you have two distribution functions. It's basically some form of a convolution between them. But then if you don't have it, if one of the things is a distribution function, and I think it's called a WGAN, because GANs without the Wasserstein, at least in some of the papers I've skimmed through, I haven't even done the legwork in a reduced dimensionality space. Seems like if you use a GAN, they've got really bad properties. They're very brittle. I think the optimal value, I mean, the optimal solution they find is very brittle. That is, if you do something like cross-validation, remove a few points or add a few more points, you get wildly different, optimal solutions. WGANs, which uses the Wasserstein metric, that's the loss function, seem to have better properties, better robustness.
So what are the particles you're trying to plot?
This is the difficult transport problem. That's one of the research projects that I've worked on that I was really interested in, and I'm still working on it. It's really hard to, with some of these really challenging transport problems, it's impractical to do the full Monte Carlo transport from this, source to the detector far away. It's not only far away, but it's
Forgive me,
sort of
what do you mean by
obscure.
transport problem in this space? I don't have what do you mean by a transport problem in this space? I don't have a physics background at all.
Oh, so like for instance, you want to model, okay, this reactor that's going off, out in the air, and you want to have your detector maybe a kilometer away. And if you want to accurately model, this detector response, if you try to do it in one shot accurately, like get the full spectrum, it turns out you need too many simulation particles to get, good enough statistics at your detector. But if you do it in stages, say at least one intermediate stage, you can probably get good statistics into this, intermediate surface, and then good enough statistics from that intermediate surface to your final detector. The secret sauce, so to speak, is, well, the particle distribution, the flux that's going through that surface is not going to be trivial. It's not going to have some analytic form. It's going to be multidimensional in time and space and, particle energy. And furthermore, this thing will have maybe a lot of, high, small dimension, space dimension structure. That is stuff that's, peaks and valleys that take up much less space than the whole parameter space. It's not smooth throughout. So to represent that with, even a standard KDE is hard. Representing that with a histogram, you could try to do that, but you'd run out of space because if you want something to finally resolve, the small parts of it, it's got to be fine everywhere. And if it's 6-dimensional, then you're going to run out of space. And if all you've got are the particles themselves, if you want to be honest about it, your statistics are going to be pretty bad for most of it. So it's wasteful, and you're going to run out of space when you do this. So the idea was using a kernel density estimator, where your your distribution function comes from the relatively small number of particles that are used to construct it. The using a WGAN is, well, what I have right now is a single, covariance matrix for all the particles. But if we use something like with a unique covariance matrix per particle, and if we've got some kind of, better sort of food to optimize that and characterize that, posterior distribution function, basically create the cloud of plausible points around it, then maybe we don't have to go this way, which really lives in the world of smaller dimensionality lands, relatively few particles. All the papers that describe, how to do it in R, for instance, all their examples are at most 3-dimensional, and they're limited to like 4,000 or 5,000 points. Actually, in most of the papers, they're like under 2,000. So it's nice and all, but I've got a very high dimensional space.
Like
And maybe
how
there's
high dimensional are you talking?
6 or 7, actually
Okay,
6 in
okay.
my case, because it's a surface. So
Hmm.
it's not it's 2 dimensionals in space, 3 dimensional in velocity. And then for time dependent problems, it's time. That's the 6th one.
And you were thinking about Torch just because you've heard bad things about TensorFlow. It's just it happens to be the machine learning
Yeah,
platform
I
that
haven't
that makes
actually
sense.
used either of them. So
I'm really curious because I'm looking at a potential second machine learning capstone, and I'm looking at doing a neural network thing, and that might be an interesting problem to approach.
if you want to go down a rabbit hole, sure, I can.
I hear there might be rabbits in the rabbit hole stuff.
I kind of know what the reduced dimensionality looks like, but to make it work, it's got to be 6-dimensional. So
Multidimensionality doesn't seem problematic from where I'm standing as a machine learning
and
thing.
there's boundary conditions too. You've got to worry about bleed outs. It's sort of like there's a concept in Fourier transforms like the Gibb offshoot. Maybe bleed out. Yeah. So yeah, exactly. So for instance, particles going through a plate, right? It cuts off at the edge. There can't be any particles outside there because it does. Yeah, because you don't have anything there. But to represent that hard cutoff, there's choices you can make, and maybe they make sense or not. And I still don't have a great intuition on that. Yes,
Sasan,
I'm a big fan of actual useful documentation because I've become an asshole at work about that. I think it was I was in a workshop about using tools. How come people aren't using these tools that we're developing? And my first question was, well, is the documentation crappy or not? And that's sort of that was basically water on the flame of discussion and I followed up. I'm not going to use it if it's impossible for me to figure out, and nobody else will either.
seems fair enough to me.
Yeah.
Wait, so Sasan, you've used PyTorch, it sounds like, but mostly failed to use fast AI. Fast AI is in fact slow AI due to documentation issues.
Well, if the documentation is extraordinary, that's a necessary condition for me to use it. It's like, if I have to be able to figure out what it's doing, how to get it to do what I want it to do.
Yeah, fast AI, I mean, the code itself looks very pretty, right? If you know what you're doing with machine learning, it looks very nice and it's very simple to just whip up a model. But reading the documentation and reading any of Jeremy Howard's examples is impossible to read. He uses like 1-letter variables. His documentation is no description at all about what anything's doing. And everything is boiled down to just a wrapper for PyTorch. So overall, unless you're familiar with machine learning and all the neural net models, I would highly recommend avoiding fast AI solely due to the silly documentation. But it's fun watching Jeremy Howard. Because he's the one who made the framework, right? Watching him maneuver around the library, like it's nice. It's cool. It's I wish I could just what's the word? Like twinkle toe my way around the framework, but I just can't. It's impossible.
Well, the problem with that is then nobody can follow you, or nobody can follow him, and I'm honest. I'm like, you're doing a lot of stuff, but how does that help me?
Exactly. Yeah.
So for your particle problem, do you have like a data set that you need to do transformations to on hand, or do you like simulate a thing that you're going to then do
No, I
more
have
things
it.
to?
There's just basically, here's a pandas data frame of here are the particles with their weights too. Or even make it simpler, just transform it into ones where they have uniform weights. And I just need a PDE or PDF to accurately represent that. And so now I have a particle distribution function. It's got some Python structure, but at a low level, it's these cloud of particles with a unique or single covariance matrix, and then just sample from it. That's what I do, and then transport that sample distribution out to the detector.
So you need to build a system to model the transportation problem the kind of interference
actually the
that's happening.
code, there's a transport code that does the actual transport. Once you give it a source, it does the transport to wherever you need it to go. It's the how do I accurately represent a distribution function? Now the source, the physical source, it's simple. It's like some kind of point source. The intermediate thing, that's tricky. And it just has to go up to the detector.
Accurately represent the distribution. So like after it's been transported, you end up with a distribution of these things and you're looking for a way
at this intermediate surface, for instance. It's intermediate so that it has good Monte Carlo statistics to it, enough particles there. And then I can resample that to get good statistics at the detector.
So you want to use the machine learning platform to build a description of what comes out, basically?
Of the PDF, exactly. And it's going to be conceptually simple. It has to optimize on the optimal covariance matrices it finds for each particle, centroid in this, distribution function. And they can be unique, covariance matrices per point.
Sounds like a problem with deep background, but from the machine learning perspective, doesn't sound too bad.
Yeah, I just don't know how to do it.
Interesting.
I mean, I could do it with the standard, root finding methods, but the dimensionality of the space, it's like, what is n choose 2 times m, where m is the number of particles. So if I have 1,000 and it's 6-dimensional in nature, ooh.
Not intractable though.
I know it's not something you give to a computer to solve in the traditional sense.
Right. Curious. I'd love to follow up with you more about this to like scope the problem more, because I'm now like really curious to see how one might actually do this. It doesn't sound.
You know what? I can give you some of the data, the actual thing to you if you want to.
That would be neat.
Just get on Slack. Get on Slack. Tanim is pretty responsive on there.
From the Slack links you posted earlier. Yeah. Okay.
Yeah, those should work.
Cool.
Hey, that'd be awesome if you guys worked on something. Figure out something with PyTorch.
I mean, it's definitely pipe dreamy, but it doesn't seem impossible.
And so, if I've got something where here's a collection of, particles, I already know there's fast algorithms even in Python using NumPy to say this is a collection of, Gaussian, PDFs, one for each point, and each one has its own covariance matrix. How do I?
When you say PDF, do you mean Poisson distribution function?
No, it's a Gaussian. I think you have.
When you say PDF, what do you mean then?
Particle distribution function, particle density function. Yeah.
Okay. It's important to know what words mean.
And acronyms.
And
Those
acronyms.
Yeah, I was with Brian. I was like, wait, which PDF? Did you send a file or?
Oh, no. It's not the data format.
There's no attachment on this email. I'm sorry. Awesome. Well, all right, we're getting close to the end of the allotted time here. Got any other questions for Tanim? Cool. Well, this is awesome. I really want to do some more interviews in the future. Tanim, I might need to lean on you to talk to some more.
Yeah, they might. I don't have too much pull. I can't provide alcohol or drugs. So I
All
don't know. Or money.
Well, I'll see what I can do about that. I'll start reaching out. I've been trying to get this guy I used to work with at a place who wrote a thing. Hopefully he'll show up for an interview. He previously looked at what we were doing and was like, well, all my lectures are on YouTube, so you could just watch those. I don't have anything new for you, but I'll write the next thing and maybe then. But he's getting old, so I'm a little worried, but maybe he'll show up for an interview. That'd be kind of cool. But this has been great. Cool. Well, all right, guys. Thanks again for showing up. This was a fun one. We're on again December 2nd. I believe Sanjay is going to be showing up for that one. He's with a group called Akasa. John Stubler, thank you for setting that up. Hopefully that all works out.
He wasn't able to make it today, but I'm on him. He'll be there for the 2nd.
That'll be great. And, no pressure. We'll get him in at some point, but hopefully December 2nd, we'll see Sanjay. Once again, everyone, Dr. Tanim Islam from the world of dopeness and occasional Python. Thanks again, Tanim.
You're welcome. And we should follow up, Caleb, if you want to. Okay.
Yeah, get on Slack. It'll be nice to get the conversation going because
I'm working on getting on the Slack right now. I'm really curious.
Sure. I don't know how much bandwidth I have to go into deep. I mean, because it's been a long day for me. So.
I like today. I'm probably gonna find you and then be like, "Hi, you exist," and then disappear.
Yes. I'll have, I'll have some brain juice in the morning, definitely.
Awesome. Well, thanks again, everyone. We'll sign off on that. Another good SAC Pie. See you guys in a month.